Alrighty, nerds, today is the day. Unit 3, trigonometry, baby! God, I love trigonometry. I love trigonometry more than I love logarithms. I know.
What I thought you were going to say.
What'd you think I was going to say?
Yeah.
What?
I thought you were going to say I love trigonometry more than I love my kids.
More than I love my kids?
Yeah.
That's a little bit extra, don't you think? I mean, I love trigonometry as much as I love my kids. How about that? I don't want to say more. Trigonometry doesn't talk back, you know what I mean? Anyway, starting trigonometry, and we're beginning the unit with periodic phenomena. A periodic function is any function that repeats its y values on regular intervals known as periods. Think about breathing, heartbeat, waves of the ocean, tides, things like that. These phenomena repeat the same activity as a steady pattern. The most famous periodic functions are the trig functions, trigonometric functions. You should have learned about them in geometry. Would have been nice if you learned about them a little bit in Algebra 2. I don't know if your teacher had time to get to it or not. And those three basic trigonometry functions are sine, cosine, and tangent. We'll get to those in another lesson. Other examples of periodic things in nature: light waves, sound waves, waves of water, phases of the moon, the clocks as they go around and around, sewing wheels, Ferris wheels, bike pedals, gears in motors. Okay, periodic motion is everywhere. So we've got visual and verbal vocabulary, academic vocabulary. Let's talk about these first, and then we will put them on here as we go. A periodic function is any function that has a repeating y value pattern at regular intervals on the x-axis. So this is a periodic function that we're looking at right there. What is a cycle? A cycle is one piece of the pattern, one complete pattern of y values. Okay? So we could say that's a cycle because it repeats after that. Or we could say that's the cycle. Or we could say that's the cycle. Okay. A cycle is one span of the repeating structure. Cool? So let's say, just make life easy, let's say from here to here is one cycle. So a cycle is a structure. Okay? It's the repeating bit. The period, though, is the horizontal length of the cycle. So it's how many x's, how long, quote unquote, did it take for one cycle to occur? So the period is the length of the cycle. The cycle is just the structure. What is the length of this period? 6. In real world examples, there will be units applied to the length of the period, like time or things like that, okay? Oftentimes it is time that we measure periodic motion over. And amplitude. Well, I goofed up the definition of amplitude in period 2. I wasn't thinking. Amplitude. This is half the distance between the maximum and minimum values of a function. Now that's not new vocabulary, but here's a maximum, here's a minimum, okay? Half the distance, okay? The amplitude is a measurement. It's a distance. And just like period, a distance, our distances should always be positive. I could say I went 3 feet left. I could say I went 3 feet right. We don't have negative distances, okay? So how do we guarantee that our amplitude is always positive? You could either use absolute value bars all the time, or you could always just do maximum minus minimum, and then it says half that distance. So your amplitude, I've already drawn, let's do purple. I've already did purple. Blue. Your amplitude is max minus min divided by 2. And it is a distance. And if you do the maximum value, y value, minus the minimum y value, and divide by 2, you will always get a positive number. So what does that look like on the picture? whoops. No, I did that right. This is the amplitude. This is also the amplitude. It's a positive number. It's how far from the middle does my wave reach. It goes one up, it goes one down. This thing has an amplitude of 1 from the middle. And I'm assuming that's going to pop up in a later lesson, but this thing in the middle is called the midline. That's what we call that, a midline. So the amplitude is literally how far can my graph get from its midline. Cool? Again, I'm sure, I would bet my teeth that midline is coming up in a very soon to happen lesson. Maybe even Monday, okay? Okay. I showed you when I was putting my hands up cycles like that, and I showed you different ways of measuring them. But I didn't put words to it. For each function, identify one cycle, but do it in at least 2 different ways. So I'll hit you with the first one. I'm seeing that my repeating pattern could begin here and end there. And of course that's begin and end because these things go on and on forever, right? And who's to say that was a true beginning? Why couldn't I have said it began there and ended there, right? So that's one way. Who can tell me another way using vocabulary? Yeah, Adi? Yeah, he says peak to peak, but maximum to maximum. So from max to max is also a period length. And what's one more? Somebody else, Sebastian? Minimum to minimum is another way. And it doesn't matter which one you choose. How far apart are the green circles? How far apart are the blue circles? How far apart are the orange circles? Just look at this, look at the x-axis. 4. That means we have a period length of 4. So things that are true that didn't actually make their way onto the box up above. If maximum to maximum or minimum to minimum is a whole period, then what happens if I give you a maximum to a minimum? It's half of a period. So if you go from max to min or min to max, you have half of a period. And that's important. I don't know, where do you want to say that? Like right here maybe? And of course it could have said minimum to maximum, half period. What about, I had something I wanted to say. Where'd it go? It just left my brains. Well, I'm drawing a blank on the other thing I wanted to say. Hopefully it comes back to my mind while we're working. Hopefully. Anyway, yeah. So max to max, whole period, min to min, whole period, max to min, or min to max, half period. Oh, I remembered. Here we go. Okay. What's always going to happen between, what can you always find between 2 maximums? Halfway between them? A minimum. What could you always find halfway between 2 minimums? A maximum. And what's always going to be halfway between a minimum and maximum? Well, this thing in the middle, which I've called the midline. It is an inflection point, but it's a midline hit. But we'll talk more about that when we have to actually graph these functions with their midlines and things like that. Because it's really important to me that you understand that something critical always occurs 1/4 of the way through the cycle. So if I go from blue to blue, 1/4 was a max, next fourth a midline, next fourth a minimum, last fourth the midline again. And the same thing happens if we do it from max to max. 1/4 midline, next fourth minimum, next fourth midline, last fourth maximum. It's almost like these things are cut into 4 pieces, isn't it? How about that? We're graphing stuff, right? What do you know of in graphing world that has specifically 4 things? Not functions. Graphing in general. The quadrants. Quadrants 1, 2, 3, and 4. It's not an accident. There was a hand up. What's up?
Is the midline always going to be the x-axis?
No, the midline is not always the x-axis. It can be shifted up and down. But it's a horizontal line, but it's not always the x-axis. It can be shifted up and down. But again, we're not even supposed to know that terminology yet. So you keep the midline and hush hush, okay? All right, this thing. We've already talked about we could do middle to middle, we could do max to max, we could do min to min. This one's middle is a little bit harder to identify. The reason why is because this one's middle line, I'm not even going to call it a midline because this is not trig, but this one's horizontal line that cuts it in half is not on the x-axis. So because of that, I would argue that it's easier just to go max to max or min to min to figure out how long your period is. It really doesn't matter. What is the period length for this one? It is 3. And like I said, if it is a real world example, then there will be units assigned to the length of this period. Cool? Okay. Hey, just out of curiosity, because I'm a nerd, anybody know the time between high tides or the time between low tides? What were you going to say?
I was going to say like phases of the moon.
Well, it's caused by
Caused by that.
It's caused by the moon, yes, but it's not phases. And it's not 6 hours. It's 12 hours. Because one day is roughly 24 hours. So
My dad's fish is
high tide to high tide should be half a day. Roughly. It's roughly because the length of our day is not perfectly 24 hours, but it's close. Okay? Just like the length of our year is not perfectly 365 days, but it's close. Do you guys know that's why there's a leap year? Because it's not perfectly 365 days. It's roughly 365.25 days, and that's why we have a leap year, which means we have an extra day once every 4 years. Happens to be this year. And did you know that leap years coincide with the Summer Olympics and the presidential elections?
every 4 years.
Well, what else happens in a leap year? COVID? 2020?
2 weeks.
But when was the last? No, because there's been 2 other, I don't know, MERS and SARS. Were they both in leap years? We're going to have to wait to see what happens.
If you look at all like the biggest pandemics,
Yeah.
Spanish flu was not was it 19 or 1820? It's like the 20.
Happening on leap years?
But it was like the 20.
So the leap years, harbingers of death. Got you. All right, so determine whether each function is or is not periodic and then find its period. Hey, I'm looking for a class of, how many of you guys? There's 21 of you and you're all here? I want 21 voices. Okay, I'm just looking for a yes or no. All 21 of you, including those of you that are looking at your phones. 21 voices. Periodic, yes or no? Go. No, it is not periodic. You know why? Because the y values do not repeat. Is there a pattern? Of course there is, but it's not periodic. It does. We can't. It might go back down, but from what we see right now, it does not. Okay. But this one clearly is periodic. So yeah, this is periodic, and I just need someone to shout out how long is the period length. 4. Yep, and that is because we go from x equals 0 to x equals 4 to see that that period length is 4. So easy peasy, right?
Yeah, for now.
Yes, for now. Amplitude. So remember what the amplitude is. The amplitude is the measure, the distance from the middle of the graph to the maximum or the middle of the graph to the minimum. But it is a distance. So in order to guarantee that you always get a positive number, the easiest thing that you could do is maximum minus minimum and then divide by 2. Max, min. So we say amplitude is max value minus minimum value divided by 2. This will guarantee a positive number. So we have 1 minus negative 2 over 2. That is 3 over 2, 1.5. So we have an amplitude of 1.5.
I was gonna say why is that working, and I realized I wasn't.
Oh, yep. -2. That way when you subtract the negative, you get a positive. So even if the maximum and minimum values are both negatives, if you do maximum minus minimum, you will always get a positive result. So then we look at this one. Actually, let me switch colors. I see a maximum at 4. I see a minimum at -2. This thing's kind of my 2's because that's 2, that's 4. So our amplitude would be maximum minus minimum. That's going to give me 6 over 2. I have an amplitude of 3. So we're talking about how far up and down one of these graphs goes. Think about transformations. Amplitude. Which transformation would that be when I change the amplitude? Vertical. What kind of transformation? Dilation. So changing the amplitude is a vertical dilation, which is another reason why we need that to be a positive number. Because remember, putting a number on the front is a vertical dilation. If it's negative, that's a reflection. That has nothing to do with changing the size of the object. So that's another reason why we always want to think about our amplitude being a positive number, because it describes the vertical dilation that would have been done to the parent function. Cool with that idea? Awesome. Real world connections. Actually, periodic things are extremely real world. Sound waves are produced by periodic changes in air pressure. Think of them as ripples, but through air instead of through water. Sketch the graph of a sound wave with a period length of 0.004 seconds and an amplitude of 2. If we attempted to do that on this graph, there would be 250 cycles from x equals 0 to x equals 1. So it would just look like we colored the page. So in order to make this happen, what we're going to have to do is we're going to have to change the scale of this graph. So instead of counting by ones, we're going to count by 0.001s. There, now it counts by 0.001s. And it really doesn't matter where we start our wave. We could start our wave at the middle, the maximum, or the minimum. It will not matter. So because it doesn't matter, I say we just start it in its middle. I say we start it at 0, 0. Okay. We know that the period length is, my goodness, I'm going to pause the video. Anyway, if we start at 0, 0, with a period length of 0.004, we know that our cycle will come to an end at 0.004. So think about one of the shapes of these things. In fact, if we go to this one, halfway between the beginning and the end, our wave was at the middle again, wasn't it? So halfway between those two middle hits, we were at the middle. So that means I'm going to be at the middle right here. And it doesn't matter if we decide for this wave to go up or this wave to go down. That, again, doesn't matter. So let's have it go up first, because why not? So that means I'm going up to a maximum, down, back to the middle, down to the minimum, back up to the middle, maximum, middle, minimum, middle, maximum. And for real poos and giggles, we can even go backwards if we want to. Look at this thing. Now these are not straight lines, they're curves. And because this thing is centered around the x-axis, every time it hits the x-axis is an inflection point. Concavity and discussions about it are coming up soon. Yes, Mark?
Could you draw the graph one shifted down one?
Shifted down one? No.
Why not?
Because when there's silence, I'd say the volume is 0. Ow, I just bit myself. I'd say the volume is 0. So these Y values are representing a level of sound. Cool? Okay. If you want to think of it that way, there's no such thing as negative sound, but that's...
But what if there's like something that you don't know what it means, like what they're trying to represent, and you draw it shifted down?
So you want to know in what real-world situations would it be shifted off the x-axis? It's actually, there's really easy ways to think about it. I've wrote a question back in the day. Talked about do you guys know what a paddle boat is? Like one of the things with a steamboat with the big spinning wheel at the back? Okay. So some of that wheel is underwater. Some of that wheel is above water. So what you could do is you could say that the part that is above water represents all the positive Y values, and the part that's below water represents all the negative Y values. And since the middle of that wheel is not in the water, I think typically the middle of the wheel is above the water. The middle of the wheel represents what I've been calling what is the midline. So if you shifted the midline up, you could model a paddle wheel's like motion as it dips in and out of the water, things like that.
Are they going to do more criteria for this?
What do you mean more criteria?
Because the criteria just states the amplitude and the
Oh yeah, eventually you'll have more knowledge. Yeah, for now that's why I was like, we could have drawn it down, we could have drawn it up. I mean, you want to have it centered at x equals 0 because we like that. That makes life easy, but yeah. Yeah, what's up? Yep, up 2 and down 2 from the middle. Yep, that's what that means. Amplitude. Alrighty. So we're gonna stretch reality a little bit and use an example that, even though it is periodic, the numbers don't work perfectly. But that's because we're just trying to make our lives easy right now. Consider how the pedals on a bicycle rotate as the bike is being ridden. The height of a bicycle pedal varies periodically as a function of time. The maximum height is 18 inches, and the minimum height is 6 inches, and that means from the ground, because obviously your pedals don't hit the ground, right? Okay, so here, maximum height. Here, minimum height. First thing we need to do is we need to finish this table. So we went from maximum height down to minimum height. Now we're on our way back up to maximum height. That means we're writing these numbers but in reverse until we hit maximum height again. So I've got the 9, then 12, then 15, back to 18. There. So what is the length of the period of this function? 2 seconds. Remember, the length of a period goes from max to max. Or from minimum to minimum, but minimum's only on here one time. But max to max is on here, 2 seconds. Amplitude. Let's get an equation. Amplitude is maximum minus minimum divided by 2. 18 minus 6, 12, 12 over 2, 6. And this is inches. It's AP, so make sure you're always putting your units on there. So an amplitude is 6 inches, and then it says graph the function for 5 seconds. My table only goes to 2, so we're going to have to really extend this thing. Graph it in purple. All right, 0, 18. And the next time we're at a maximum is 2 seconds later. The next time we're at a maximum is another 2 seconds later. The first time we're at a minimum is at 1 second. But we'll be at a minimum 2 seconds from then. Oh crap, I missed it by 1 dot. Then we'll be at a minimum again, 2 seconds from then. And halfway between every minimum and every maximum, halfway between them will always be the dead middle of our graph, which halfway between 18 and 6 is 12. So at 0.5 we're at 12, 1.5 we're at 12, 2.5, so on and so forth. And I'm not going to put the other dots on there. You know why? If I put the other dots on there, this thing is all straight lines. But that's not how circular motion works. So I'm going to have just the peaks, valleys, and middles. And I'm just going to draw a rough sketch. Circular motion is never going to give you straight lines. Adi, your brain is turning. What are you thinking about?
There's like in the straight lines,
Mhm.
like infinitely cut it in half.
Mm-hmm.
Each one will be a midpoint, but when you get to the curves, it'll stop being a midpoint on the circular lines.
Yeah. And well, that's the thing, too. So think about it like this. If you were pedaling and, you know, you're dealing with the pedal motion, oops, you know, if that was a circle, yeah, this point is exactly, like you're talking about the midlines, this point would be exactly half the distance from these two. But this one on the edge of the circle did not cut any distances in half, did it? Like, it ends up being weird fractions, like root 3s and root 2s and things like that. There's actually a root 2 here because of the way, if you think about triangles work, if that's 90 degrees, then that's 45 degrees. But 45 degrees make triangles that go 1, 1, root 2. So they're not pretty anymore. It's not a half. Now it's a root 2 distance. So yeah, so that's why it's like, in reality, these numbers don't actually work. But at least it gives us an idea. It's just an example. Oh, okay, remembering something. All right. And the last part of today's notes, and we'll call it quits there, is right here, putting it all together. A periodic function goes through 5 whole cycles in 4 minutes. I would like to know what one period of the function is. We're going to get it in seconds. I think the easiest way to do it is to use a proportion, which you would have done in like 7th grade math if it had a 2 on the textbook. If you were one of the advanced people, then you skipped 7th grade math and you went to advanced 7th grade math, which means you might have missed proportions, which is really unfortunate because, man, are they useful. So here we go. 5 cycles per 4 minutes. So one cycle then would be how many minutes is the real question. You guys know how to solve a proportion? Anybody know? Yeah, Mark is doing this with his hands. It's called cross multiply. You have to cross multiply to solve a proportions because there's an equal sign in between these two fractions. So it gives me 5x equals 4. Now you divide both sides by 5, and what you get, x is 4/5 of a minute. That is the length of one period. Oh, but it says in seconds though, doesn't it? Not divide by 60. Multiply by 60. 4/5 of 60 is 48. So some of you are sitting there thinking, well, that's not, I mean, I would have just did 4 times 60 to get 240 seconds and then divided that by 5. And I would say to you, that's exactly what I did. Here's 4 times 60 divided by 5. It's exactly what I did. I just represented it in a proportion because proportions are powerful mathematics. The period of a function is 8 seconds. How many cycles can it get through in 30 seconds? What do we have to do to figure that out? Yeah, it's literally just straight division. It's just 30 divided by 8. All right, 8 goes into 33 whole times. That's 24. Gives me 6 over 8, which is 0.75. So 3.75 times. So you can get through almost 4 cycles in those 30 seconds. 3.75 cycles. So that was 3.75 cycles instead of times. There. And the last one, we're going to use our equation for amplitude. The amplitude of a periodic function is 2.5. The minimum is 0. What is the maximum? He says it's 5, but here's the formula for that in case you're not common sensing your way. Max minus minimum over 2. And we figure out what we know, fill it out. We know the amplitude is 2.5. We don't know the maximum, but we do know the minimum is 0. Multiply both sides by 2. 5 is the distance between the maximum and 0. Oh, I guess the maximum is 5. I'd say that's a nice, easy beginning to the trig unit. Thanks, nerds.